Let's start with exponential equations. Let's try to solve 3 to the power of 3x equals 9 to the power of x plus 2. This is a very easy one because I can express 9 as 3 to the power of 2 to get this. Now I can use rule of exponents to get that. Because we have 3 to the power of something equals 3 to another thing, we know that the two exponents has to be the same. The reason is because the exponential function is 1 to 1. I would like to recall that usually I always told you that if we have to solve equations, we have to write everything to one side of the equation equals to 0. This is not true in two cases. One case is the exponential equation and another one is logarithmic equation. The reason is because this function is one-to-one function, which means that if 3 to the power of a equals 3 to the power of b, then a must be equal to b. And in this case I get that 3x equals 2x plus 4, and I can solve this easily to get x equals 4. There is also a different way to do it. I'm going to apply ln both sides. And when I use the power rule for logarithm, I get 3x times ln of 3 equals x plus 2 times ln of 9. I distribute the x plus 2 with ln of 9, and the reason is because the unknown, the variable, is x, and x plus 2 contain x, which is a variable, and I need to find it, and 2, which is just a number. Don't forget that ln of 3 and ln of 9 are just numbers. Now, because I need to solve for x, I want to have all the x's on one side of the equation. And I get that x times 3 ln of 3 minus ln of 9 equals 2 times ln of 9. Now I can just do division and get x equals 2 ln of 9 over 3 ln of 3 minus ln of 9. Don't forget again, ln of 9 and ln of 3 are just numbers, so this is a good solution. The first way, which was really much easier than the second way, was possible when the bases are the same or when both have power of a common base. But the second way, by applying ln both sides and work it out, is always possible. I just want to show you that these two answers are really equal because they look so different, but they are equal really. Because now I'm going to write 3 to the power of 2 equals 9 and see what happens. Every time when I have 9, I'm going to write 3 to the power of 2 and I get that. I'm going to use the power rule for logarithm and I'm going to get that. And now you can see easily that I get 4 ln of 3 over ln of 3, which is 4. Logarithmic equations. Let's solve log base a of x minus 1 equals log base a of 5x plus 1. Exponential function has no problem with the domain because the domain of the exponential functions is all R. But I would like to recall that the domain of logarithmic functions are only strictly positive numbers. So here we have a problem, because when I look at this, I have to talk about the domain of this equation. We have one function on one side, which is log base a of x minus 1, so x minus 1 has to be strictly greater than 0, and x greater than 1. And here, 5x plus 1 must be greater than 0, so x must be greater than negative 1 over 5. But because we are combining in this equation those two functions, we have to combine the domains by intersection, because the solution has to be okayed by the log base a of x minus 1 and also by the log base a of 5x plus 1. So we'll do the intersection. In this case it's pretty easy. We get that the intersection is x is greater than 1. So this is the domain of this equation. Because logarithm is a one-to-one function, and if you can see we have exactly the same base here, then it must be that x minus 1 equals to 5x plus 1. Let's do the algebra. We get that, and we get that x equals negative 1 over 2. Bad news. There is no solution to this equation. The reason is, please look at the domain. The solution was x equals negative 1 over 2, but the domain is only x's which are greater than 1. It means that this equation has no solution. Example, let's solve the equation log of 5x plus log of x minus 1 minus 2 equals 0. We will start again by inspecting the domain of the problem. From the first one, 5x is strictly greater than 0, so x is strictly greater than 0. For the second one, x minus 1 is strictly greater than 0, so x is strictly greater than 1. The intersection is x greater than 1. Now we are going to make sure that we have in this equation and all logarithmic equations, all the logarithm on one side of the equation and all the numbers on the other side. And we get that. Now we are going to combine the logarithm. And we get that. Now we have to apply the exponential function, which is the exact inverse of this logarithmic function. And because this is log base 10, we have to apply the exponential function 10 to the power. On the left side, we get just 5x times x minus 1. On the right side, we get 100. Now we have to solve the non-logarithmic equation. This is a non-logarithmic and non-exponential equation, which means that all the rules of solving equations are going to be applied here. For start, we will have to write everything on one side of the equation and 0 on the other side. Okay, before I'm just dividing by 5 to make it easier. Then I have to write as product of terms, and then I have to solve each term to be 0. And I get this. When I observe the domain, I see that this is not a solution in this case, and we get the solution of x equals 5. Now I'm going to show you a slightly different way how to do that. We are going to express the non-logarithmic side of the equation as a logarithm with the same base. It means that now I'm going to replace this step by this step. 2 is always log base 10 of 10 to the 2. And now I can go and do exactly as before.